smart. Now, we did decide to take a little bit off the quiz because 5th period is shortened ever so slightly tomorrow. Not like 6th and 7th. They're pretty much cut. But we did not put the word problems on there. So because we did not put the word problems on there, will there be rounding up that you have to graph? No. So just like 1, 2, 3, and 4, we're all rounding down. That's what you'll see on your quiz tomorrow. Okay? So you don't have to worry about the barbell going the other way. All right, let's take a look at number 1. Number 1's a great problem because it's just like our parent graph. There are no horizontal stretches. There are no jumps. Well, there is a jump, just by 1. Okay, so we're going to shift right 4 and down 2, and that's our first step. We're going to jump up by 1 and down by 1. And when we do, we'll notice that the domain of every step function is negative infinity to positive infinity, which you could write as all reals. Yes, sir?
So tomorrow, basically the closed circle will always be on the left?
Yeah.
Okay.
And then the range is the set of integers. So you can write out the set of integers. You can do the double Z. You can give me the pattern. You can say dot, 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 negative 3, negative 2, negative 1, 0, dot, dot, dot. All right, so just give me some correct form of the answer. Okay? Number 2. Number 2 has several changes with it. This one was shifted up 1, which is why my original barbell begins right there. And then it has this horizontal stretch. Remember, when anything happens to the x, we do the opposite. So the opposite of dividing by 3 is multiplying by 3. So this has a horizontal stretch out 3 units. And then because of the 2 in front, it also has a vertical stretch, which causes me to jump up by 2. Now, when you jump up by 2, you either get the set of even, or in this case, we get the set of odd. And how do we know the difference?
Because you started at 1.
Because we started at 1. So we started with odd, so it's the set of odd integers. So you could write that, or you could describe the pattern. Any questions? Are we making corrections if we need to? Okay. All right, on number 3, we got the negative out in front, which means we go downstairs instead of upstairs. So we're going to start at negative 2, negative 4. It's going to be 2 units across because of our horizontal stretch by a scale factor of 2. And then we're going down, jumping down. So my domain is a set of real numbers, or negative infinity to positive infinity. And the range, once again, is all the integers. So you could do the double Z for the set of integers. You could write the set of integers, or you could describe the pattern. Questions?
No, ma'am.
All right.
Wait, I have a question. So how do you know you're just going down 1?
Okay, the reason we know we're going down is because this function has this negative right there.
Right.
So when it has a negative, once you draw that first step, instead of jumping up, we gotta jump down.
Right, but why is it only 1?
Okay, the reason it's 1 is because there's that understood 1 out in front. So in this one, we jump by 2 because there was a 2 out in front. On this one, we jump by 1 because it was that understood 1 out in front. Now this one, we're going to jump by 3. So we're going to shift left 5 down 6, 1 unit across because there's no horizontal stretch of compression. And then we're going to jump up by 3. Jump up by 3, jump up by 3, jump up by 3, jump up by 3. Now, this one happens to be multiples of 3. Every time it has a 3 in front of it, it may not be multiples of 3 though. But because I started at negative 6, which is a multiple of 3, it works out this time. So on these kind, you might find it best just to state the pattern. Make sense? All right, rounding up, rounding down. Well, I gave you down, 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 up. Okay, how do we know the difference? The up has the top bracket, And down has a couple choices. Down could be the double bracket, it could be the single bracket, or it could be the bottom bracket. All three of these mean down. This is our only symbol for up. Okay, so check 5, 6, 7, 8, and 9.
You tricked me.
I did by making that last one up. Alright, so here I have the square root of 8. If this is a rounding down, it would round down to 2. Because the square root, I didn't give you that one. It's an extra bonus. It's a little bit less than the square root of 9. And so it would have to be a little bit less than 3. And it would round down to 2. And then pi would round down to 3.
Because it's 3.14.
That's right. Alright, now this next section is over evaluating piecewise. So we just evaluated stat, well, greatest stanza. Now we're going to evaluate piecewise. So the first thing we have to do is determine which equation does it go into. In this case, we have a top one and a bottom one. So we determine the equation, we plug it into that piece, and we get our results. So check 1 through 6, and then I'll scroll down so you can check 7 and 8. Yes, sir.
On the test, are we going to need to specify which one we plugged it into?
No, I only wrote top, middle, bottom because this is my key for students to look at. I would not have done that on the test. On the test, I probably wouldn't even show my work. I would just write 16.
That's what
But
I
if
did.
you show your work, it gives me a chance to get partial credit.
So we should have to figure out which equation it goes into.
That's right. Like this one, 7 is greater than 4, so it's got to go in the top one. I'm a little jealous. I did not get Zaxby's for lunch.
I didn't either. It's really good. It's really good.
That is interesting. Now it's on the mystery. He did not do Zaxby's for lunch, yet he has a Zaxby's cup with ice in it.
You sure with us?
Yes, he's crunching it.
That could be anything. Could be some like Beatles or something. Could be a pencil, maybe a
I
pen.
hadn't considered that. True. Alright, 7 and 8. That's why you're my favorite class.
I thought it was gonna be the smartest one.
Put that
Oh,
on
that's
record
right, that
so
too.
they can hear it.
And we make you laugh.
This will be my math shoes came in. Wanted to order the math. They came in.
I like those shoes.
Thank you.
You wanted those or not?
Yes, he did.
And you
He'd
didn't
been
take
wanting
his
them for a
phone
long
away?
time.
Finally came in size.
I need to get new shoes. These ones are old.
I'll take them off your hands. 35 cents.
Okay, check
And a
out 7 and 8.
brand new copy of Call of Duty 3.
Check out 7 and 8. See if you have any questions.
I got nothing. What does this mean? Easier. 19?
Is it basically the same thing we just did?
Zebras, mangoes, and trees.
You get negative 2.
It's basically going to be negative 5 times negative 2 plus 1.
What kind of cereal is this?
You rearrange it for the next one.
Oh, describe.
Makes
We
sense?
talked about this yesterday.
So can you just like plug in a random number that's in between the less than and greater than?
Well, it's got these guys.
Oh,
Is it
that's
chocolate
what that
flavor?
appreciated big dough.
Big pepper.
Cinnamon
Big
flavor.
dough. Negative 2 times.
I
5.
had to do it that hard.
No. So? Or minus. You live by the sword. 19. That's all right. Because I live by
My
the
question
sword,
myself.
die by the sword. For Lisa's looking for me.
Cinnamon. Cinnamon.
All right.
Oh, you're
Look at us. We're making nice pace here.
Wait,
Oh, we need to go back.
are we not going over?
These. Oh, I skipped right past those. Sorry. I get it. All right. So yeah, let's go over these. Let me erase what I have here so we can start from the beginning and make sure we understand. All right. If I give you a piecewise function and like on this one, I ask you to write it as an absolute value function. Did I skip some? Okay.
Yeah.
10, 11, 12.
I did. I went through several
And
slides.
That
I'm
junk is
really
easy.
sorry.
We don't need to do that stuff.
No, we do need to do this. Okay, so let's go back to this first. Alright, this is write a piecewise function to represent this absolute value function. I have two methods here. One, sketch the graph and do it like you do 10, 11, 12. The other method is the algebraic method. I want everybody to pay attention to me for a second. When we do just algebraic and we're not looking at a graph, to find the left side, what you do is take this, do the opposite of everything inside the absolute value. You see it became a negative x and a positive 2. And then if you distribute, that gives you the equation for the left side. To get the right side, you take everything that's in the absolute value and leave it the same. And then you distribute and combine like terms, and that gives you the right side. And you can verify that by looking at the graph. So, if you like the graph, do it that way. Or you can do it the algebraic way, which is to find the left side of the graph, the left-hand part. You take everything in the absolute value, switch it to the opposites, distribute, and simplify. To find the right side, you take everything in the absolute value and leave it alone. Don't mess with it. Just distribute and add by terms. That gives you the right side. Now, how did I know this was 2? Because that is the x value at the
Origin.
vertex.
Where's that?
Okay, so take a minute, digest number 9. I bet most of you are just gonna sketch a graph if I give you one of those.
Is today a work day after this?
No, we're Kahootling, which is good because right now there's Christmas music playing in my head. It's a little premature for that, so some good Kahoot music. Kahoot.
Kahoot.
My brother next to me.
Kahoot. Music.
Ooh, go Owls.
Alright. Okay, 10 and 11, 10 and 12. 10 and 12 were the easy ones. Those were the ones where it was the y-intercept was given to us, or we could just count back and find it. Number 11 took a little more work. So look at 10 and 12 first. See if you have any questions about the easy ones. Then we'll talk about the harder one. The middle one was the harder one.
Isn't that 3 over 4?
Which one?
2 or 11?
I think it's down 4 over
See,
3.
now my breath don't smell.
Oh yeah, I went over. Why did I do? Okay, never mind.
Alright.
I got it right, but like I did.
It's not one
But I know
over
my
one.
mistake.
Okay, so questions about 10 and 12. doesn't cross pretty. It doesn't cross the y-axis nicely anywhere. So what do you do when it doesn't cross pretty? You have to use point slope. Okay? So remember, point slope is y minus y1 equals m times x minus x1. And what we have to fill in are these things. The x1, y1 is from a point that's on that line. So if we're trying to do the left half, you pick a point that crosses nicely. I picked the one I circled in blue. So my x value was -4, so minus the -4 made a +4. And the y value at that point is 0. And then you plug in the slope for that ray. Up 4 over 3, 4/3. Now, I don't have to move the 0 over because it makes no difference. I distribute the 4/3 and I get the equation for the left side. 4/3 x plus 16/3. There we go. 4/3 x plus 16/3. Now for the right side, I did the same thing. But this slope is down 4 over 3. So this slope is -4/3. And I picked the point circled in green, which is the point 2, 0. So I plugged in 0 for my y and 2 for my x, and I distributed, and I got the equation for the right side. So the left side is represented for x values that are less than or equal to -1, because -1 is the x value at the vertex. And the right side is for x values that are greater than -1. Now, I get to pick. This one could have the equal to and this one not, or this could no equal to and this could have the equal to. Equal to is in one spot or the other, but not both. Okay, does that make sense? For number 11. When they don't cross that y-intercept pretty, you have to use the slope and the point and plug it into point slope. I do see a few people correcting their work. That's encouraging.
We're the smart class. We're the smart class.
That's right. Maybe I'll grade your quizzes first tomorrow. I have a sinking suspicion. Yeah,
Suspension?
I got one of those. I got a suspension too in the van. But I didn't bring it
Oh,
in today.
wait.
I drove the big truck, so y'all be careful leaving the parking lot. If you see a little old lady sitting in a really big truck, that's me. I'm not good at driving it. It's too big. What'd you say?
Huh?
Be careful, the big truck.
What's your husband driving, man?
He's gonna take we had a brand new van this summer, and one of the warning lights came on, but it won't indicate what it's for, and we can't figure it out.
That's what
So
happened
he's
to me.
gonna take it in.
You just
get
have to
checked
hit it
out.
a few
Oh
times.
god.
It's a brand new van. We're
Or
not hitting
or
anything.
just turn your parking brake off.
Alright,
Hopefully it's just.
parking brake is not turned on.
Yeah, I drove with the parking brake for like 2 days.
So you no longer have a parking brake.
Nope.
Yep. Alright. Let's talk about number 13 now. We're finally there. So, if you're given a piecewise function and asked to create the absolute value function, the first thing you have to do is plug in the x to find the vertex. So in this first problem right here, my x value is 2. So when I plug in 2, I get 10 plus 2 is 12. Well, what would happen if I picked this 2 and plugged it in here? Guess what I get? 12.
12.
So it doesn't matter. So now we have the vertex. So you put the vertex into vertex form. Remember, vertex form is a times x minus h plus k. So we're putting in our hk. We're putting in our vertex. And then all you have to do is choose the coefficient from the right side. Alright. So how do I know if it's the right side? That's the greater than. So we're going to choose the coefficient from the right side, which in this case is -5. And that's how we get it. So once again, step 1, plug in Half of 4 is 2. 2 plus 5 is 7. Put in your 4. Put in your 7. You're doing the coefficient of the right side. Positive 1/2. Are we good? All right. Now, how do we do these? The first thing you do is you plug in your x to get the point that you start with. This point is going to be an open circle going left. So we do an open circle, less than left. The slope is positive 1, but if I have to go left, that means down 1, left 1, down 1, left 1. Keeps going in that direction. Now this one has a start and a stop. And there's no place to plug it in. So this 3 has to be the y value. So it goes from 0, 3 to 2, 3. And it's just horizontal line segment. And then finally this one doesn't fit on the graph. But if we plug in 4, we get out 6. It starts right here. The slope is positive 1. We're going right. So up 1, right 1. So it goes off that direction. Now this graph is not continuous because if my finger can't trace it without jumping. So the domain of this function, left to right, goes from negative infinity to negative 1, and then from 0 to 2, and then from 4 to infinity. Those are the x values. Now the range is a little odd because this is an interval of y values. This is an interval of y values. But this segment right here is one single y value. And we haven't really looked at one like this before. So we do an interval that represents this first ray and an interval that represents the top ray, but this is a single y value. So instead of using interval notation with the parentheses, I have to use set. I have to go back to the braces. It's not an interval, it's one y value.
So it's just a line on the y.
Yep, so there's a y. Now this has that line, but do you see how on this one it's connected to other stuff? So it makes an interval. This little y value hanging out all by itself. It's not connected to anything. So it does not form an interval. Alright, so let's go to this one. This is that horizontal ray going left. Now this is an absolute value. That's the v. So this v has a starting point at negative 3, 3. Because when I plug in negative 3, the absolute value of negative 3 is 3. It has a stopping point at 3, 3. Because when you plug in 3, you get out 3. And we know that this equation, f of x equals the absolute value of x, has a vertex at 0, 0. Then we just connect the dots and that gives us our v. Alright, and finally, we plug in a 3 and get out 3. And we're going right this time, so we go down 1, right 1, forever. Now, did you notice how the closed dot got circled by an open dot, and the closed dot was circled by an open dot? This one's continuous. It is not missing any x values or y values as we travel left to right.
Wow.
Continuous, domain is continuous range. Alright, any questions about 15 or 16? Last two.
Goodness.
Last two. Now, I need to apologize because I think I forgot to tell you to change this plus to a minus. And so you got an awful large number when you plugged in. You got,
Got 12.
54.
Or
Yeah, you got 154.
Well, you got 27.
Yeah,
And then you
times
multiply by
2.
Yeah.
Yeah. So you got the point 154.
Sorry.
I'm really sorry. I meant to tell you guys yesterday
it
to
was
change
two.
this to minus, and I failed to do
Massive
so.
number.
So if you don't have this little piece of the puzzle right here, totally understandable.
Get out of here.
I did not tell you to correct it, so you did not know to do so.
We're not wrong.
Dang. think makes more sense. Not much.
Yeah.
Okay, but do check the rest and see if you have any questions for me.
You're not wrong.
For 18,
Yeah, check 17 too.
but on the bottom part of 18.
Bottom part of 18. This right here, you
Yeah.
won't have that.
Okay.
You can only have that if you knew the right point.
Oops, unstable.
Well,
You didn't know it because I didn't give it to you.
well, Mitchell had it because he had your answer key,
That's right, Mitchell did.
and he gave it to me.
Oh, what a nice fellow. He shared it with you.
But wouldn't it be over one, down one first? From the
Okay, so what would happen is this cubic right here, if I had given you the right one, would have a vertex right here. And because of the 2, we would go over 1 down 2. That ends up being this point that you would have gotten. And then we would go over 2 down 16, so it would be totally off the
Oh,
graph.
so that's the second point.
Yeah. So this is actually the second point of the graph. And I oopsied on my answer key. I didn't even notice this. So let me fix that back again. I put that point in the wrong spot. There we go. All right. What other questions might you have before we play Kahoot? And today's Kahoot game is not comprehensive. It's difficult to make a game out of piecewise functions. It will ask you some particulars about them, but you're not going to have to grab a piecewise function in a Kahoot game like you will tomorrow on your quiz.